Good afternoon. Welcome, everybody. This is IOT205, Insights for a Connected World. I'm Ryan Burke. I work on the AWS IoT team as a software developer manager on the IoT Console and customer experience. I'm joined today by my colleague, Michael Garcia, from the IoT team. And from Salesforce, we have Bo Mangels and Aubrey Wing. So what to expect from this session? Today we're going to talk about what are operational insights, how can we get them from the IoT console. We just launched a new version 2 of our console last week. We have a new analytics service that is in limited preview, and how we interact with AWS IoT and the Salesforce IoT Cloud. We're going to be talking about 3 main pillars of analytics, and then I'll give a quick walkthrough of the IoT console. Some of the new features there. We'll go through a demo where I have a sample implementation on top of the new analytics service. And then we'll have a lifecycle demo using our solar panel kit, which shows how a device connected to AWS IoT can interoperate with the Salesforce IoT Cloud. And then we'll summarize with a value of analytical insights. So the new AWS IoT console, why are we launching a new one? Well, customers told us that the first iteration of the console didn't give them a great picture of what was happening with their IoT solutions at a high level. It was difficult to onboard new devices. It was hard to find devices once they were onboarded. And so what we've brought here today is some new capabilities. So we have a new dashboard for operational insights. You get that top-level view of your account. You can see connections being established. You can see messages being published in and out of the account, rules activity. We also have full-page detail views. So we used to have like a slider pop out when you were clicking on a resource. So we brought that into a full-page view. Makes it easier to read everything and find what you're looking for. We have a new low-friction connection wizard. There are a lot of steps to connect a device to the service. So now we have like a 15-minute process. It's a little wizard. You tell us about the device, the operating system, the version of the SDK you want to use. We give you a little script to run on your device. Downloads and installs everything that it needs, and then gives you a little validation that the device is connected. We have more search options. So when you have a big fleet of devices in your account, you can search for them by name. You can search for them by the thing type or the thing attributes that you give to the thing. And so I'll give a quick demo. Some of these new features. So at the top, I have the top-level dashboard. So a couple of graphs here. We have those connections that are coming into the account. These are going to be the MQTT connections that get established. We have some donut charts about messages going in and out of your account. So you can break down by protocol, whether they're using HTTP or MQTT. We have lifecycle events like connect, ping, and subscribes versus the publish message type, which is the actual data plane messages that your devices are sending in and out of the service. And then we have directions. So inbound messages are going to be those that your devices are publishing up to the cloud. Outbound are going to be those messages going out back down to the devices. We have another view of messages published. It's that inbound and outbound, but now it's a graph over time. And so I can zoom in on these guys and kind of get more information about individual data points. I can turn on and off certain graphs. We also have rules executed. So as messages are being published in your account and generating rule activity, you can see how those rules are being executed over time. And then at the bottom here, we have shadow updates. So if your things are using the device shadow service, those get, update, and delete calls, you can see the relative success versus failure of those calls across the account. So I'll dig in here into our new thing registry, device registry interface. So we have that same card view here. It's a lot easier to find things. I can search for something like solar, and I can get all of the hits against solar here. I can search for something called solar panel simulator. That shows me all of the simulators, or the devices of type solar panel simulator here. It would also match the name if it matched the name. So I'll step through creating a new device real quick. We'll call this one Johnny 5. We'll give him a type of robot, and a serial number 12345. So we've registered a new device. Here's that full page detail view. We can see the type that's associated with this thing and the serial number that I gave it of 12345. I can click on these magnifying glasses and jump right back out to the registry interface, and I can see that I'm searching for anything matching the word robot. And so Johnny5 here has a type of robot, and so we can pull him up. Same thing for attributes. Searching for that serial number equal to 12345. This one's going to come up. I can clear this out and just search for serial number as an attribute, and it hits against Johnny5. We have call outs to the security certificates, the IoT device certificates. This one is brand new, so it doesn't have any security set up. We have quick call outs and little wizards to help get security set up very quickly. This is the device shadow for Johnny5. It's a brand new device, so he has no state just yet. And then new feature, the device activity tab will show me what's happening with this device as a real-time feed. So we have an MQTT WebSocket interface here. It's listening for any IoT lifecycle events like connecting, subscribing, disconnecting. It's also listening to those device shadow topics. So if this device is updating its shadow or other agents are updating its shadow, we'll see that activity here. And so to demonstrate that real quick, come out here to our test client. So this is an MQTT WebSocket client. I'm going to actually disconnect as the default ID and connect as Johnny5, so that all of these actions are being generated in the context of that device Johnny5. And so I'm going to just make a random subscription here real quick. So Johnny5 is connected and subscribed to this topic, ASDF. And then I'm also going to publish a new device shadow update. Where I update the state of this device and so all of this activity could be, I'm simulating it as a device here in the console, but I come back here and I can see all of these events have come in real time. So I can see that the device connected, I can see that it subscribed to this topic, I can see that it updated its shadow. And then we also see that the shadow has been updated in this tab over here. So the new detail view is great for operationally understanding what your devices are doing in real time. Okay, so coming back to the slides. So the reason I go into the console first, it gives me a frame of reference for talking about analytical insights and why the new console is helpful in determining them. But there's really three pillars of analytics that we want to focus on. The first one is descriptive analytics. These help us understand the past of a device. What happened? Descriptive analytics are going to be dashboards, visualizations, trying to help us answer what happened in the past. We also have predictive analytics, which is going to help us tell the future, what's going to happen. How can we forecast what is going to happen based on current data or past data. And then third, we have prescriptive analytics, which define using the combination of past, present, and future to ensure specific outcomes or recommended outcomes. So descriptive analytics, as you see here, it's going to be looking at something like a dashboard where I see all of the data that has come in that is being stored and help me answer questions about what's been going on. I also have predictive analytics. Examples of this would be fault detection or fault prediction, fraud detection, anomaly prediction. And then prescriptive is going to be a combination of both descriptive and predictive analytics to help me figure out something like if I look at the past of this device and I can see that over time it's getting hotter and hotter and hotter, and I can predict when that threshold is going to be met when the device would overheat. Well, I can set a rule that says, hey, don't let this device overheat, if you predict that it will overheat, go ahead and power it down, or flag some CRM tool that a technician has to go out and service it. So I will go through a quick sample implementation based on this new analytics service that we're building. So with this blueprint, starting at the kind of the back left, I have my solar panel simulated devices. They're publishing up to the AWS IoT service, which is that second icon. The third icon represents a rule in our rules engine. So this rules engine is going to be listening on the topics for my solar panels, and it's going to be sending data over to our new IoT Metrics analytics service, and it's also going to be sending data over to a Lambda function. And so what this Lambda function is going to do is it's going to look at data as it comes in real time, and it's going to compare that present value against the fleet metric. So we have all of our devices being aggregated into like one fleet metric of watts that are being generated by these devices. It's going to compare the current value against the fleet aggregate and say, hey, is this device inside or outside a certain margin or threshold of what the fleet is doing? It might indicate that this one device is unhealthy compared to the fleet. We're also going to be comparing the present data point of that device against its own history. So over time, if it's about 5:20 p.m. and the current value is 20 watts being generated, if we look at yesterday, is that higher or lower? Is it abnormally higher or lower? If we go back a few days and look at the data, are we trending upwards or downwards? And then based on that analysis and using the metric service to make that determination, we can send a message, an alert back to the IoT service. So that's the very top icon. It goes from Lambda back into IoT. And then I can even store that as an additional metric where I can see the history of devices that have been in some kind of abnormal or alert state. And so our IoT metrics service that we're building, it stores data up to 2 weeks. It also aggregates data at 3 dimensions or 3 levels. So I can see when I define a metric, I pick a data attribute. So in this case, my solar panels are generating a metric or a payload with the watts being stored. And so in that JSON payload, this rule is going to pull out any messages that have the watts key in the message. It's going to take the value and stuff it into my IoT metric. And I can build a metric for wattage generated for the entire fleet. It's also can be broken down by every rule. So a rule is going to have a new action. I can pull that up on this other screen. So we have a new rules engine action called IoT Metric, and this is going to be pulling messages out of this topic filter here and sending it into a new metric I've defined called sim watts, because these are all of my simulated solar panels. And the value that I'm pulling out the state.reported.watts key out of my payload going in. Now, I can have multiple rules that all report into this same metric name, sim watts. And so rules become a second hierarchy of dimensionality for this metric. So that when I'm pulling the metrics out of the service, I can say, without any dimensions, just give me all of the metrics for this fleet. Or I can say, based on this rule that was inputting data into my metric, pull out that aggregate. I can also go down to the third dimension, which is the thing. So all the way down to individual things, we can pull metrics out of this service. And I can compare, how is this device performing over time? How is it compared to this kind of grouping that's being clustered by the rule? Or how is it being compared to the entire fleet? And so I will step through the Lambda code that I am using to compare values coming in. Oops. So Lambda is going to be pulling messages in from the solar panel in real time. And then we're going to pull that current wattage value out of the payload, and also the name of this device out of the payload. And so I have five things that I'm looking for as this Lambda function evaluates. The first one is I want to compare the present value to the fleet aggregate. So I'm going to make a call out to my metric service, and I'm going to get the fleet aggregate value for that metric. And I'm also going to be looking at the full 2 weeks of data. I'm going to pull the average aggregation function out of that. And I'm going to compare the current value of watts with the most recent value of the fleet metric. And if we see a margin, say greater than, I think I have 30% here, we'll throw an alert back to the IoT service that says, hey, this device is deviating from the current fleet norm. And so that's the first thing I'm looking for, is how does this value compare? How does this one device compare to the fleet average? The next thing that I'm looking for is comparing the present value to the history of this thing. So yesterday at this time, what was the thing doing? What was the wattage being generated? And if that is abnormally different, I think I'm doing a very similar thing here. Yeah, comparing for like a plus minus 30% percentage difference compared to the thing from yesterday. So again, we make a call out to the metric service. In this case, I'm just getting the full 2 weeks because I knew I was going to use the full 2 weeks later on in this function. And then I can see the dimensions that I'm specifying. One is the rule name. So this is the rule I was showing in the IoT console, piping messages into the IoT metric. And I also need to specify the thing name, so I only pull the metrics out for this particular thing. And then same kind of thing, I look up a value in my metrics. This is all code that I've written here in the Lambda function based on the response from the IoT metric service. And I do that comparison and say, hey, look at the present value, compare it to a value that I've looked at from yesterday. Am I seeing something drastically different? And if so, I'll send an alert back to IoT. The third thing I'm looking for, so in steps 1 and 2, I've used the present value of the fleet to augment my insight, my understanding of what's going on with this device. In the second example, I'm using the past to help me understand more about the future. And so I think what is more interesting is using the past and the present to help me tell something about the future. So in this case, I am using both the thing history and the fleet history of this metric to answer, is this rate of change of this device faster or slower than the rate of change of the entire fleet? And so I'm pulling out all of the data from the past 2 weeks of the fleet metric and the device metric. I'm running it through a linear regression function. And then I'm comparing the slope of those differences and saying, okay, is this device changing faster, dramatically faster than the rest of the fleet is? To tell me if I need to send some kind of alert. So this tells me, I can start to learn more about the present, about how the rate of change is affecting the device's health. In step 4, I am going to try and forecast a potential data failure. So now that I have this slope and the linear regression of how my device has been operating over time, I can use the intercept of that linear regression to say, hey, is this device going to meet some threshold? In this case, it's just the y-intercept, which I'm calling a failure. When is this going to hit the y-intercept and trigger some kind of failure state that I have defined? And so we can say in this code, based on that linear regression, figure out when we're going to hit the y-intercept. And if that timestamp that I generate is within the next 30 days, hey, go ahead and send an alert back to IoT. This is something that needs to be looked at. Yep, so this, in just a couple lines of code, this is all of the logic of the Lambda function. Everything else down here is just helping me manipulate values from that metric service. But with just a couple lines of code, I have four new insights that I've generated based on just that present data that the device was sending up to the service. I have more insight about the present value than I had before because of the metric service. I have more insight about the past of that device, and I can also start to predict the future health of this device with all of that information. So that's just an example of a sample implementation on top of this new metrics service. Oops. Might help if I showed the output of this. So on my dashboard, as part of this limited preview of the metrics service, we have a new graph down here for the custom metrics. And so if I pull up my simulated watts here, I can see the number of times that wattage generated is being published into my account. If I change the aggregation function from count to sum, I can see in a 5-minute period, or each of these 5-minute periods, just how much power is being generated by my entire fleet, because I am at the top level dashboard here. And then if I switch it over to average, I can see, hey, how is each device contributing to the total? And so my simulated service of solar panels comes online in Maine and California in the morning, and so this is the kind of the nighttime. And then as the sun comes up, I've got more and more power being generated. And then if we come in here and look at a particular solar panel, also a part of the limited preview, we have a new metrics tab here, and I can see those similar lifecycle events and message direction graphs from the top level dashboard. How is this one thing contributing messages and connections to the service? But I also have this custom metric graph down here. And so I can see how this guy is contributing to that one wattage metric. You know, what is this individual device's contribution? Cool, and then so anytime in that Lambda function when I evaluate the present data and find one of those thresholds that I'm looking for, I'm actually republishing a message back into IoT to have another metric, another custom metric from this new IoT analytics service, so I can start to track, hey, how are each of my devices failing or contributing to the overall number of failures in of my fleet, to get kind of a rough estimate of how healthy the fleet is. And so I have another metric here called the Sim Solar Alerts, and I can see that, oops, let's change the time frame back to a day. I can see that because of how I set up the simulated solar fleet, in Maine, all of my devices are experiencing cloudy weather, and so when I had the service running for the past couple hours, I had a lot of those alerts telling me, hey, your devices in Maine are abnormal compared to the rest of the fleet. So this is an example of the descriptive analytics. Is a human operator coming and looking at a dashboard, looking at graphs, trying to get that operational picture of service health. And then if I were to hook up those alerts coming back into IoT, I can hook that back up to another rule, pipe it back out to something like SNS for notifications. I can notify a human or another operator or another agent to take some action, which is a great segue into how we integrated this physical solar panel device with the Salesforce IoT Cloud. So I'm going to spin up this demo here. It needs about a minute of generating data. And so I'll have my colleagues Michael Garcia and Bo Mangels come up.
Hey, what's up, guys? So first off, thank you for that awesome overview with AWS IoT Analytics. So first, it's like we kind of want to, while Michael's over here starting to assemble our solar panel farm, one of the first things that we want to actually take a look at is what are we actually looking at when we see this graph that's actually in front of you. So through everything that Ryan discussed, he talked about how AWS and AWS IoT is leveraging all of your device data to assign meaning behind what those devices are actually putting out. So what you're seeing is if you have 10 billion devices in our use case here, which is our solar farm, what we then have is saying, it's like, well, what are the commonalities between things that we see? And from there, you're going to run all of that directly through AWS IoT, and it's going to land within Salesforce IoT, where you can then take the insights that you're seeing from AWS IoT, and I know I'm saying a lot of IoTs here, so just please track with me, and assign business value to that. And what do we actually mean by business value? Well, it's great to be able to have and understand all of this device data and what it does, but the main thing we need to do is we need to be able to add the human element to it. So in our use case that we're about to be able to walk through, we're going to basically simulate what a solar farm would do. So if any of you are from Nevada or from the Western United States, you know that there are hundreds of these that are all sitting around with 40,000 different solar panels that are popping up. And we're actually going to walk through this particular use case using our 3D printed models here that Michael's going to actually start walking us through today. So Michael, do you want to show us, as we attempt to do our best Abbott and Costello impressions, what are we actually taking a look at when we see this today? What is this?
Thanks, Mo. So
Yeah.
what you can see is multiple solar panels, because we'll be simulating a solar farm. So you have a couple of solar panels here. You have a Raspberry Pi that is here, and then a board, integrated circuit, that has a few components. This is just to establish a link between the solar panel and the Pi, so we can get the value out of the Pi. So with this setup here, everything is connected to AWS IoT, and it's sending data. So every 3 seconds, it's taking a snapshot at how much the solar panel are generating power, and it's sending that to IoT. So we can actually visualize that on an Elasticsearch dashboard. So this is what you see there, and it's refreshing every 5 seconds with the latest data. So all of this is live, and to prove it, maybe Bo, you can pass your hand
So here
above
are the
it.
clouds that are going across the sky. My hand is a very lovely and beautiful cloud. So it's like we're going to go ahead and see. We're now actually starting to see dips within each of the solar panels that are being affected.
So as you can see, there's a lot of solar panel, and you might have noticed that we have 4 here, but there are many more on this graph. The reason is we have multiple prototypes of this demo. Others are in other places, in other rooms at reInvent, and we have 3 of them, and one of them is running live. This one are solar panel ID from 5 to 9, actually. So if I wanted, I could zoom and just, for example, select one of them.
So Michael, essentially what we're looking at is we're watching all of the solar panel demos that are across all of Vegas at this point in time that are running.
Exactly.
Got it.
And if I was an admin, I could just select like this one and just take a look at one of the solar panel in particular, and I could also have a graph with a view that would give me other metrics. So here we are doing a little bit of aggregation as well. We can see the power that has been generated by the solar panel, and here the number 5 is our winner. Apparently, it's the one that have been generating the more power. So once we have this data in AWS IoT, we're able to visualize it. Now maybe we can act on it, and for that we are pushing the data to Salesforce IoT Cloud. Mm-hmm. Bo, can you explain what we are seeing on that graph?
Yeah, absolutely. So as you saw, within the Elastic Cloud charts, you're actually being able to watch and monitor what every single one of those solar panels are doing at any given point in time.
Sure.
What we are now taking a look at here is we're hopping over into Salesforce IoT Cloud. The bubbles that you see in front of you are the steady states that we understand from what we already know about how solar panels are actually functioning. So right now, if we were to look across all of Las Vegas, 50% of our solar panels are actually operating efficiently. Those are the panels that we're actually taking a look at now. And 50% are actually in need of on-site repair, which those are the ones that are happening, I believe, over in the Venetian or something like that. And so, which one is a really exciting thing for us to be able to say, it's like now you're actually seeing all of this live and in real time. But ultimately, what are we doing and how are we actually getting to this state? And why does this actually make sense to us? And why do you want to take a look at this if you actually are managing a solar farm? So, again, back to Ryan's earlier point, when it comes to analytics, you're pumping in all of this analytics data, and you're trying to make sense out of it. So what we at Salesforce have done is we've created, what you're seeing here is like a fairly straightforward state machine that allows us to then assign rules to each of the corresponding states. So let's say there's a potential solar device issue, or we need to be able to leverage a cleaning action. Most of this stuff is done based on customer insight. Most is like just leverage experience. But now what we're trying to do is we're seeing this from an analytics perspective. So we're actually being able to see this in real time.
So you could combine the data that is coming from AWS IoT, from the connected devices, with data that is in Salesforce, like CRM data, if
That
you
is
wanted to.
absolutely correct. So what we're going to do now is let's actually go ahead, let's walk through it.
All right.
Let's have some fun and let's actually walk through this. So first of all, we'll go ahead and add a disclaimer. So many of you who have been in conferences before, it's like you've done live demos in person. We're doing one that doesn't operate on one contingency. We're operating one that runs on 5 based on our lights, our models, all of our conference Wi-Fi that's here. So if you pray to demo gods, go ahead and shoot one up to them and say, let's make sure that we make this really, really wonderful. So first, let's go ahead and let's say we're going to do a potential solar device issue, right?
Yes.
So it's like right here.
So let me pull up the other graph so we can see the difference, actually. Stay a little bit up on the same one, over the same one. So here we're going to see some drops in there, and we'll see the value are different, and then it should go into this state. And apparently, you did not pray enough to the demo gods, because this should have moved. So let me just redeploy this. Oh,
Nope.
all right.
There it goes.
It moved. So it's just the UI that I need to refresh then. So what actually happened, and we can go back to it, is that what Bo is doing, putting his hand over, we see the drop in the value in there. And the business use case that we have is that if you have a solar farm, it has to produce a lot of electricity, right? If you have dust on your solar panel, then it means that you have to clean them because otherwise they will produce less electricity. So with the hand on top of the panel, we're actually blocking the lights.
Correct.
And doing that, it means that we want to clean them. And in our demo, cleaning them is just actioning, making use of the motor to turn them.
Right. Exactly. And I think to build off of that, one of the business contexts that we want to really propose here is at any given state, when you have a solar farm, you're having about 4,000 to 5,000 of these per one service technician. The service technician can't possibly serve all of these at one time, so if we can write business logic rules with an IoT cloud that can then pass into AWS IoT, then potentially, as we've done here, we've already triggered the movements so that we're actually self-cleaning them. So no technician is actually required. But now let's actually simulate a case to where it's like, what if something actually gets stuck? Which we have here with this is going to be our tumbleweed because we are in Nevada. And let's go ahead and let's block this off.
So, all right.
So now we'll go back to the traffic view.
So what's number, this one, number 8.
And so we now see that this one particular dish is now receiving no power at all.
And so now, because of the state that we can have in here, the red one, the on-site repair, Salesforce created a case for that solar panel number 8
Correct.
that we can see here. So if I'm a technician, I can go ahead and then choose the case, see that it's solar panel 8 in whatever location happened. And so then I can also see the description. So I can see in Salesforce data coming from AWS IoT because apparently the voltage of the solar panel was 1.024.
Yes.
So that means that as a technician, I could have access to debugging information. I could also, thanks to a link, go back to the AWS IoT platform and use, some of the graphs showed by Ryan to make sense of the data a little bit more. And then, for example, choosing the right toolbox. I know it's this type of solar panel. I've seen this issue before.
Right.
So it's probably that issue. So I need to take those tools.
Correct.
So what happens then? So I'm on site.
So you're on site. You're most likely accessing Service Cloud from a mobile device, but in this particular use case, it's like we're going to say you're running out there with one of those Toshiba Superbooks. You work through you walk through Sales Cloud, you understand what the fault is and the problem is. We go ahead and switch the status from new to closed.
So we have to do the repair, right?
Yes, of course.
So let's switch to the webcam to show you the repair. It's a very technical step.
It's a really intense moment.
And here it is. I'm an expert.
I'm glad
with
you're
solar
safe.
panel.
Yeah, I'm glad you're safe there. Okay, so we've now actually repaired our solar panel.
Yes.
We're back up and running and functioning. And so I'm going to go ahead and switch the status to close. I'm going to click Save.
And now we can go back.
And now we'll go back here.
Oh, so something changed, right? On the blue, I have customer confirmation.
So that's customer confirmation. So that means that we've actually come through here, and we've actually confirmed that this panel is now fixed.
Okay.
So it's like we've closed this. We're now back on track to being all the way to normal state.
So if I'm an administrator, let's say I can see, again, with this panel, the technician does the repair in a B2B scenario. Then I could wait and maybe confirm other checkpoints before saying, OK, I'm good with the repairs.
Absolutely.
OK, and in a B2C scenario, then if I have a technician that comes and repairs the boiler in my apartment, then I can wait to get a hot shower, make sure it's fixed.
Yes.
And then say to the company, OK, I'm good.
Yeah.
And how do you do the confirmation then?
So
what can you use?
we actually use the confirmation. So the confirmation that we can use here is within the AWS IoT button. So I'm going to go ahead and click.
You can show it maybe when it's beeping.
So it's beeping right there.
So pray to the demo god once more, please.
I might have accidentally clicked it beforehand.
All right, green.
OK, so now we've gone back to green. And yeah, it looks like all of the solar panels here are actually operating, functioning.
Back to normal now.
We're all back to normal.
OK, good.
Great.
Yeah, very good. All right,
Perfect.
so then we can use all the data in Salesforce with the rules, connect all the objects that we have to securely with AWS IoT, and make use of the data in Salesforce.
Yeah, with the whole point of that being, and one of the main value adds in which we see, it's essentially merging human expertise as well as what we know from device data, right? Yeah. So all of the device data is coming in and being managed from AWS IoT. All of the human context data is being managed within Salesforce IoT. And together, it's like we can help build an end-to-end solution for really solar farms to robotics manufacturers to fleet management tools. Anything that you want to be able to do, we can do it.
Great.
Yeah.
All right.
That's it.
Thank you.
Thanks. Thank you. And it works. It works.
I just need to turn that light off so I can see again. So coming to wrap this all up, you know, there's two takeaways that I really want you to come away with. One is that there's kind of a pitfall of the term analytics. A lot of people think, hey, I want to build my solution, and then I'm going to put some kind of analytic solution on top of it and just measure it, and you know, understand the health of that system, help me make future business decisions. But really, analytics you want to start thinking about at the start of a business solution, during every part of the development cycle, at the end, and then start it all over again. You want to think about analytics as a data model, which is a question. You're going to form a question. What do we want to learn about this system? Start with your questions up front, and then your solution, you can start to work your analytics into that solution over time, and then as you deploy that solution or that iteration of that solution, you can see if you've answered your question. So that's kind of one takeaway is always think about analytics at every stage, not just at the end to see if you did something correctly or not, or if something is healthy or not. Because the currency of IoT, one of the value propositions is to generate insights. You know, we can have all these services and devices, you know, up and running and not connected to the cloud, you know, kind of in a pre-IoT world. It all works still, right? You didn't need you didn't need Internet of Things to enable some of these existing solutions. So when you connect your business up to an Internet of Things solution, you're generating a lot more data, which is very powerful. It's a lot of information to wield. And so analytics can help you make sense of that data and give you new insights that you can use to inform other business decisions, or there might be secondary insights that you learn that you can sell back to the market. Like, hey, we had all of these solar panel devices, and we learned something about the tumbleweed system of Nevada because of all the technicians that we had to send out, and all of the times where just having the device rotate and clear the dirt off was successful. That's information that you learned because you connected this fleet of devices, this existing solution, up to the cloud and started collecting all of this data. And so the other thing that's important about analytics to consider is that in the implementation of the kind of the blueprint schematic that I had with the Lambda function, I'm combining real-time data about the present with more information that I'm collecting from the fleet aggregate. Also, I'm combining it with information from the past. And I'm combining some of those insights, some of those analytics, to learn something new about the service. As I was designing the simulation service, I had actually forgotten that I had set my solar panel devices that are in Maine to have cloudy weather. And so when I was kind of finalizing and testing the simulation demo, I couldn't figure out why I had all of these alerts coming in from the devices that I had set up in Maine. And it turns out I had forgot that I had set that cloudy weather, and the system was working actually as I expected it to, almost too well. And so, by combining information, say I didn't know that it was cloudy in Maine because I had told my system to work that way, I would have learned that, hey, all of my devices in Maine are operating, out of the norm of the fleet across the country. I'm going to go investigate that. I'm going to go learn about something. And then I can take that data and just put it right back into the data model and say, okay, now I know to expect cloudy weather in Maine. My devices aren't going to operate as efficiently there. How does that help my business make its next move? How do I make that next decision? And so this just kind of creates a cycle where your analytics help you understand something. You apply that knowledge to a new data model, ask new questions, and keep growing what you know and the capabilities of your system. So as I said, that new metric service is in limited preview. If you have any questions about that or are interested in trying it out, you can use this email address here on the slide. Slides will also be up on the reInvent website pretty soon after the conference. We're interested in customers to try it out. We're interested to hear about your use cases and how you might be using analytics to just not just study and understand the health of your fleet, but also how can you use analytics to generate new data models, to generate new insights. Thanks. So remember to complete those evaluations, and then we'll use whatever time we have left for Q&A.